Good morning, everyone. Welcome to the early session. Today we have Ludo and George. They did a breakdown on how many work was done with the FreeBSD project and how it was, well, basically how it was divided within the people that did it, and they made a breakdown and tried to compare it with normal software development. So, Ludo, there you go.
Well, actually, I'll leave the introduction to George.
Good morning, everyone. I have to sit because I drank a beer too many last night. I hope you're not gonna mind. This presentation is based on research we're doing at TU Delft, the Technical University of Delft, here in the Netherlands. I'm gonna go straight into the presentation, not waste your time. So the subject of the presentation is how free software is being developed. And in order to find out, we looked into FreeBSD. Let me start by saying a couple of things for those of you, probably very few, not really familiar with what FreeBSD is. FreeBSD is an operating system developed by volunteers. It derives from the Unix operating system. BSD, of course, was a key component of that effort, developed at off camera, eh? All right, so I'm gonna go back. Well, the University of California developed BSD, which was a very useful operating system, so it was still being developed. In the 90s, it was taken up by a different development group. Then there were some problems with the pace at which the project incorporated patches. So as a result of developers' frustration, the project split into two sub-projects, each one with their own emphasis, with their own special orientation. Then there was another problem with AT&T when it sued the University of California, claiming that it distributed code that it belonged to them. As a response, the University of California responded likewise, so they brought legal slander against them. And this more or less brings us to today. So we have a number of BSD descendants as a result of both the frustration of developers at the pace by which the original project incorporated code, and also because of legal problems due to people being greedy. Second slide, please. These days, it's a global project, meaning it's being developed by people residing everywhere. However, if we look at the lines of code they produce, we see that, previous one please, we see that development is more heavily concentrated in America and Europe. The range varies from 18 to 58, though the majority of people contributing code fall within 20 years and 40 years of age. If we go to the next slide, this depicts the organizational structure of FreeBSD. To a large extent, this structure is inherited from BSD itself, which is often claimed to have pioneered what is nowadays called the open source development model. So basically, the project has a core team in the center, which according to current bylaws numbers 9 people. Those 9 people are vested with authority to grant or revoke privileges as regards committing code to the code base. Radiating from them, we have the committers, who are precisely those people having the privilege, having the right to commit their own bits to the code base. And surrounding those people, we have a much larger group of thousands of people who either contribute problem reports or patches, but they have to filter those contributions through committers. So those are the people not having the ability to check their own code into the code base. However, the process by which a contributor becomes a committer is very straightforward. If you keep on bugging, if you keep on sending your patches, your problem reports to a committer, eventually they're going to get sick of it and they're going to propose you to become a committer. Initially, the same person, this is the tradition, becomes your mentor, meaning he's responsible so that you don't fuck up. And when they consider you ready to proceed on your own, then the mentor says, well, I'm no longer required, I'm no longer needed here, and you become an autonomous committer able to mentor others. This presents a more elaborate view of the various teams making up FreeBSD and how they're connected, though I don't want this to give you the wrong idea, because the arrows in this scheme do not represent authority relations. It doesn't mean that the arrow, the person who's, for instance, the core team, can dictate what the source committers are going to do. A slightly important and very interesting detail is that the core team is not only responsible for the administration of the project, they are also quite engaged in producing code. So they are also doing development work. As you see, there is a whole spectrum of different teams. Teams focusing on marketing, on vendor relations. After 2000, we have also the FreeBSD Foundation, which is geared to popularizing, creating some buzz around the software, proselytizing some companies perhaps. Please move on to the next one. As regards how software is being developed, FreeBSD has a parallel development structure like many other big free software efforts. This means that development is being done concurrently and independently. To elucidate this, consider the process by which code becomes part of the project, becomes part of the product. This usually goes like this. There is a person having written code, then they are meant to ask for community feedback, which usually means you get responses from 2 or 3 or 4 people the most. So it's not that much, but it's still helpful. So based on this feedback, if you are a developer, you either revisit your code, making the appropriate changes, and going through the review stage again, or then you proceed to the next step, which is to test it locally on your own system. Assuming this works, so you don't break the build, you can still build the system, you proceed on to committing your code to the development branch, which in the case of FreeBSD is sometimes referred to as trunk, sometimes as current branch. In this presentation, we most often refer to it as current branch. So once this code becomes part of the current branch, or to put it differently, every day there are 2 development releases made available on the net for wider user testing. So this is an automated process, meaning that every day we have 2 new versions of FreeBSD. So those 2 versions are being downloaded and massively debugged, tested by a presumably much bigger group of people, group of testers. And depending on this process, so when the code matures is considered problem-free, this code is being put into the stable tree, into the stable version, which constitutes a version of the product geared to people not wanting something developmental, something on the cutting edge, who just want a stable and usable system. Supposedly, people like Yahoo, who want something that can run 24/7 without too many glitches. This process, another important thing, I constantly forget things, sorry about that. It's important also to note that before a release is made, there is this team called Release Engineering Team, who act in a way, well, I don't want this to be misunderstood, taken wrongly, but they act as dictators of the process. This is the only team and the only stage of the development process that can be said to be limited to the authority of a single group. So this group, the release engineering team, can say, well, we no longer accept any code. This is called code freeze, and basically means that only corrective patches can become part of the code base, so only bug fixes rather than new functionality. And once this team considers the software ready for a release, they release it themselves. So if there is a dictator in the FreeBSD development process, again, of course, I would like this dictator not to be taken wrongly out of context, those are the people. Those are the ones who have absolute control over what becomes part of the code base. And once they find it ready, they release it to the world. Next slide, please. This gives a new version of FreeBSD on average every 3 months. If we look in the course of 10 years, it's more or less, yeah, every 3 months. I'm gonna pass on to Ludo now.
Okay. Well, within this framework, we asked ourselves, how does this code actually become to exist? What did people actually do? For the main difference with normal software development in open source, you find, is the people voluntarily produce their code. It's not top organized. There's no management from above telling the programmers what the hell they should do. They do it voluntarily by themselves. This, yeah. What's the next slide? To analyze this behavior, we took the CVS repository from FreeBSD and looked at which people committed what. From that, we saw that there's these numbers, in total over 300 people committing code, and the nice thing was that the FreeBSD people were kind enough in every CVS commit to note whether this was something fixing a bug or actually producing new code. So we can notice that the vast majority of these people did nothing but small bug fixes. Actually, yeah, pretty much 2 out of 3. A lot of, yeah. Sorry, I'm kind of nervous. If you look at the amount of committers, you see it steadily rising over the years. There's more and more people join every year, but they rarely leave. Yeah, pretty much. I'm sorry. Now, one interesting thing to see is the code base evolution. It keeps on increasing. The project gets bigger and bigger. Also, as the number.
Just imagine we're not here.
Yeah, I'm trying.
Slides back. I'm gonna take it here. So what do we see? As the scale of the project is getting bigger, more and more people are required to produce most of it. I don't like it up there. However, if we look at the proportion of developers required to produce 80% of new code, this remains fairly constant at 20%. So no matter how big the developers base is, it's always more or less 20% of the developers who produce 80% of the functionality. Although in absolute numbers, of course, the number rises. If we look more specifically on productivity, can we please go to the next slide? What we see here is the total number of code contributions throughout the whole time frame that our analysis focuses, which is the complete time frame of FreeBSD development. So as it steadily rises, then it stabilizes around 2002, and there is a decline again. To get further insight into what's happening there, we look at average productivity, which is the total contributions divided by the number of people who contributed them. What we see by looking at the next slide is that whereas the number of people keeps on increasing from 16 to 200 or so, their productivity falls. Why is this happening? To get even further insight into why is this happening, could you please move on to the next slide? We compared the productivity of the top 15 developers, meaning the most productive 15 developers, with the whole project productivity. What you see in this slide, the blue line is the productivity of the top of the 15 most productive committers, the group that is commonly referred to as the core developers group. And the red line depicts total productivity, how much the whole group of developers have contributed. So what we see by looking at this slide is that the productivity of the top 15 developers has not fallen because of the increase of developers joining the project. So what I see in this slide is that whatever the effect of the increase in the committers base, for one thing, it has not affected negatively the productivity of the core developers. Could you please move on to the next slide? Which means that if there is a fall in productivity, in average productivity in the project, this is not because the core developers are less productive, but it's because more people join the project who contribute relatively less compared to the core developers. May we please move on to the next slide? Past this, we don't really need it, which brings up the question whether core developers spend more time over time, meaning that they're possibly more motivated and more engaged with the project, putting more and more time into it as their engagement proceeds through time. We haven't yet double-checked this, and we intend to do so, but it's fairly logical to assume that this holds true, that core developers in the space of development put increasingly more time into it. If we look a few more statistics, we see that a good number of modules do not have maintainers, which suggests a sort of collective responsibility for approximately half the modules making up the project. If we move on to the next slide and we look at files, individual files, and how many people have contributed to those individual files, we see that there is a good proportion of files with more than 9 committers. And again, we see more or less the same tendency, that approximately half of the files making up the project are being developed in a collaborative, in a collective way. Next slide. If we look at the core developers group, the people who put most of the code throughout this time frame, could you please move on to the next slide? This shows a little bit detail. What we see here is that one core developer may be very productive on one single year, but may not be so productive on the next year. And we also see that overall, the core developers group is being regenerated. What I mean here is that even if some people die, you know, there is this classic example, what happens if Linus Torvalds die for Linux? What's going to be the effect? What I see here is that the project is not depending on 10 the same individuals. There is a dynamic by which the core developers group is being recycled. The same is being observed if we look, please, previous slide. We see here the same thing, but for those who fix bugs, for those who fix problems. The same tendency is at work in this. And the conclusion, based on those two, is that code leadership is distributed across different groups over time, and therefore, there is no need for a code god. Which, of course, as a side note, also means that FreeBSD is not being driven by a click. It's quite easy to become part of the core developers group. Next slide, I'm gonna pass again the presentation on to Ludo.
Try again, see if I can get some more sensible words out of my mouth this time. The one aspect in classical software development that originated back from I think the 60s, 70s in IBM, is Brooks' law. They found that when running to a deadline for a commercial project, management thought they could just throw in more manpower and have the problem resolve itself. They failed. What turned out is that as more and more people joined the project, they actually spent more time introducing these new people to the code. They didn't know what to do, and they had more and more overhead, and in the end they got less productive than with a smaller amount of people. To circumvent this problem, the concept of modularity was introduced from a management level. Thus, the whole code base was split up in independent sections where small teams could work on and would not interfere with each other. To analyze this, we traced through all the dependencies of the FreeBSD kernel. If you look at the code base, the small example here is, say you have these 6 files. File A includes a header and makes a function call from file B. B does so from file D. A also depends on C, etc., etc. Now, how to quantify this? This is the particular method of filling a matrix with binary data of which of the two depend on each other. Well, first, everything depends on itself. Then you have the direct dependencies, and tracing them through, because A depends on B, and then B depends on D, so A also depends on D, which goes up to a certain amount of levels. And in the end, you get a full matrix. Then you look at what percentage of the total amount of all the numbers filling in the matrix is a 1, and you end up in this case with 42%, which is an indication of how modular this particular project is. The smaller this number, the more modular it is, because the less internal dependencies it has. Now, if we look at FreeBSD over the years, what's funny to note is that where you would expect, as the code base rises, there is a need for more modularity, you actually see the propagation cost increasing. It's getting less modular and more complex and intertwined. So it's odd how open source development manages to overcome this problem of Brooks' law by not introducing modularity, but using different methods. Which is basically what's written here. Now, to kind of finalize the whole presentation, we see this as an example for a transgression from the classical 4-disk production type and commercial software development to something new. And given the increasing importance in information production in contemporary society, this is bound to have political consequences, to analyze these consequences, we would look at the nature of open source development. We see, for instance, in the ability to fork a project, there's an implementation of the right of disobedience and difference, which oh god, I'm getting into political theory. Which we also see in a lot of radical political theory. And if you look at the nature of open source development, it has a lot of revolutionary potential in a sense. If you look at this quote from our dear Mr. Marx, it pretty much sums up what people are doing in practice here. And we were also curious what your thoughts on this are. Does open source software have a revolutionary potential, or is it just a bunch of middle-class white male doing a fun thing? questions, remarks, things?
This one. Yep. Questions?
Yeah, it's a very interesting observation, but one difference here might be that because of the lack of scarcity in the software world, this kind of works here, while it doesn't have any revolutionary potential in like the snail mail physical world.
Yeah, that is true, though if you compare it to political theory 100 years ago, where there was a hegemony of, yeah, back then the industrial proletariat to form a critical mass, nowadays this hegemony is shifting more and more towards bioproduction and information production. And so I think you can conclude that this is the sector where you would form a critical mass in modern day society.
I'm not sure if I understand correctly the structure of FreeBSD. In Linux, as far as I remember, there are core maintainers with full commit rights that are responsible for managing subsystems like disk subsystem, networking subsystem, PCI, and so on. So if there is some kind of new developer that has some fix for the bug and slightly new functionality, and he does not have commit rights to the kernel trunk, he just sends the patch to this core developer and he commits. So are you sure that number of lines and number of commits made by this top 15, top 10 comes from them, or they are just behaving as proxy for large groups of developers without commit rights?
Well, it's a good question. To an extent, we cannot say, because, like you point out, it is very reasonable. It is indeed true that some people send their own code to those core developers, basically the people having the right to commit their own changes to the code base, who themselves incorporate it. So that's true. However, I would expect that not to be so substantial so as to distort the analysis, because if you contribute, if you are a steady contributor, eventually, which is very fast, they're going to ask you to become a committer yourself. To contrast it, to compare it with Linux, I would say that FreeBSD is much more easy in that a committer can check in his code directly without mediating with anybody, without asking for permission. Whereas in Linux, it's more traditional to ask the person who's considered the maintainer or the one responsible for that domain of the code. So I would say it's much more easier for a committer to get his code into the development release, into the current branch of FreeBSD, compared to Linux always. And if indeed there is a dictator resembling the management style of Linus Torvalds, or his, like you say, his ability to say, well, this is not going to be part of the code base, then this would be the release engineering team in FreeBSD. Okay. I hope this answers your question.
Yeah, thanks.
More questions?
Well, I'm sorry that I don't have a good question for you, but I just want to say that this is very interesting research, and that it appears that you have just scratched the surface. So I really want to encourage you to keep this up, because there's a lot of interesting things beyond the horizon, and so keep it up.
I have a small question about the Brooks law. To me, it seems that Brooks law may be coming a little bit from the notion that usually when you need more capacity, you have to invest in more capacity, and that takes capacity. So it gets worse before it gets better. So at first you have less capacity, but that's only on the short term, and then in the long run you have more capacity. Isn't that also related to Brooks' law?
Let me ask for a question. What kind of capacity are you exactly referring to? Like production, how many changes that commit the code base? Or?
Well, for example, the people that are working on something, so human resources, for example, if you want to educate more people so that the load is spread across a larger base of people, then you will have a lot of people working on introducing these people to the code, such as you said. So there's some overhead which causes a short-term deficit in capacity, but a long-term increase.
I see what you mean. I'm not sure it could be answered like this, because in total contrast to commercial software, there is no standard state that FreeBSD needs to be in. So it basically develops based on the needs of the people who develop it themselves.
Yeah.
So there is no milestone or the state that FreeBSD has to be in so as to employ more people, bring in more manpower. Yeah. So this analysis cannot really be done because it evolves based on the contributions made by individual developers. And this is how technical change takes place within the sphere of free software. So instead of a grand vision being laid down by the leader, you have people who put their time and effort based on how needed this time and effort they reckon it to be.
Yeah, yes, it's true. Thanks.
Did you ever compare your results with theory about self-organization from out complexity theory? Because I see a lot of parallels here, and maybe if you want to scale this to the real world or the non-virtual world, then that can give also some leads. So do you have any comments on that?
Well, we haven't done any concrete analysis comparing proprietary and free software development or free software to more conventional organizations. Though what I would expect to find is that many times hierarchy is only being introduced for power, to put it simply. So there is no productivity gain by introducing hierarchy. It's only meant to increase the control of managers over their employees, over their,
But there's, in the social sciences, there's a bit of emerging school, nice terminology in this context, of researchers who are looking at how people self-organize their projects and their work. And in that theory, I see a lot of parallels with your findings. So it might give a framework to understand. And
definitely what you say. I mean, the whole notion of emergence is that you have very simple rules, individuals following very simple rules, and something greater comes out of those individual efforts. And, taking account of the fact that free software is actually developed, it changes according to the needs of those who develop it. So it's not, like I said before, a leader who's, saying this is what's gonna be done. Free software changes in ways that it needs to change when it needs to change. And it's nothing but the result of all those cumulative efforts, all those cumulative contributions, the synthesis of those individual contributions made by individual people who basically do not follow any leaders, neither pay too much attention to rules and bylaws and regulations. I would suspect that many developers very often, and not suspect, this is what happens in FreeBSD. There are many developers who break the norms and the regulations of how FreeBSD should be developed. And research in other free software projects has also shown, more specifically in Linux, that the role of the leader is so overestimated, given that people actually do what they fancy without too much attention paid to what the leader or the maintainer fancies. So it's definitely something that could be analyzed through the perspective of emergence and self-organization, definitely.
Yes, I have a question. You have been talking about how we can use the modularity in the development of the software, and I found that very interesting. But my question is if this modularity couldn't be used also for testing the software, because very often lots of projects ask users, not even contributors, but also normal users, to test the software. But let's say that I download daily development release of FreeBSD, but what kind of things should I test that other users are not testing on the other hand? I think this modularity could be used also, having some kind of testing guideline, like, okay, you are going to download the software and you are going to please test this while other people test something else.
Most definitely, undoubtedly. However, I mean, it's beyond the question that modularity, breaking something bigger into smaller parts, facilitates many things. Finding where problems lie, more autonomous development. However, the whole notion of eliminating connections between different groups of developers, encapsulating linkages within modules, is not what modularization is doing in FreeBSD. So most of the time, so according to the whole notion of modularity within software development, the idea is to encapsulate, keep all linkages, connections within the modules, and reduce connections among them. So basically, you isolate developers within module space, and in effect, this leads to isolated groups of developers. However, by looking into FreeBSD, we see that those connections between modules are far from being reduced over time, which means that those different modules, and by extension, different groups of developers, are quite engaged in communicating and collaborating with each other. So it's quite contrary to what we would expect to find if indeed this proposition of modularity held true in this context, of course.
Do we have more questions? George. Sorry?
It's all right. I think we could go for coffee, eh?
Okay. Thank you. Interesting. Next up in Monty Hall, we've got Realizing the RFID Guardian. And the birthday tent will have locally exploiting wireless sensors, breaking AES by syringe. That actually looks nice. And hackerspace everywhere, building the future in the two envelopes here will be next. Thank you all.